Hi, everybody. Welcome to the Shuko Math Practice Lab, Learning Through Practicing. So we're going to start a new unit here. And this unit, we're going to talk about all about the L'Hopital's rule. And so the first practice, before we even go to do the L'Hopital's rule, so the first practice, we're going to focus on identify which term, is indeterminate form and which form is you can determine by just, take the limits here. Because a lot of students, they got confused. So like when they see infinity something, they will just directly apply the L'Hopital's rules, okay? So I think the practice number one is quite important. So you will know exactly what type of the form is the indeterminate form, and then we'll be able to apply the L'Hopital's rule, try to help us. Okay, so here are the practice. So we have a lot of problems, but those problems are pretty, I think it's pretty easy. We should be able to cover in one section here. So this one's basically after each one, so we will know, okay, this is the, for example, part C, this is the indeterminate or determinate form. And if it's a determinate form, then we'll be able to find the limits without, using the L'Hopital's rules here, okay? So, so this is our practice number one. And now, like as always, it is a good time to pause your video and try to do a quick, try to practice this and try to do a quick one and make sure you know how to decide it. Then afterward, you can resume your video and come back, and then we can check the answer against each other to see, whether you did your practice correctly or not. Okay, so go ahead. You can pause the video, and I'm going to go to the on the whiteboard and get ready. So when you are ready, just resume the video and let's take a look. Which one is indeterminate, right? Okay. Okay, everybody, welcome back. I hope you get a chance to practice some of the problems here. And so for the practice number one, before we start, let me try to write out some basic review, and those are the rules we're going to use to try to do this practice. So when we talk about the indeterminate form, so if you still remember, your lectures here, so the indeterminate forms, we have a few forms here. So the very basic one will be if you get a 0 over zeros, and then you have the infinity over infinities, right? So like when we talk about the indeterminate, that means I don't know what is this limit. I need to do further, manipulations here. Then the next thing here is is 0 times infinity. So what is 0 times infinity? Not sure, right? So it's indeterminate form. Then the next indeterminate forms will be the infinity minus infinity. So what is infinity minus infinity? Not sure, right? So those are the indeterminate form. Then for the exponents one, we have 0 over the 0 power, and this is indeterminate form. Then the next one here is infinity over 0, and then the next one here is 1 over infinity. So we have this 7 indeterminate form, then we'll be able to use L'Hopital's rule, try to help us. So like for these two here, for these two forms here, those are basically is the L'Hopital's rules is based on. So if you have 0, 0, and infinity over infinity, how do we find the limit? Then all the other 5 indeterminate form, we need to do some manipulations, okay? So we need to manipulate the form into either 0 over 0 or infinity over infinity. We will do all this practice in the later practice sets here. And so right now, the first thing here is let's try, make sure we understand which form is indeterminate and which form is not, right? Okay, so for this problem here, we have a few given conditions here. We have like a limit x approach to a, and the f of x equal to 0, and the limit x approach to a, g of x equal to 0, and the limit x approach to a, and the h of x equal to 1, and the limit x approach to a, and the px equal to infinity, right? And the limit x approach to a, and the qx equal to infinity. Those are the given conditions for all these problems here. We try to determine, right? Okay, so let's start. And so hopefully we can finish this unit. I think this unit will be pretty easy one. So the x approach to a. Okay, so the h of x and the px. So just like we learned from we do the the limits, right? We just plug the number. So we say limit x approach to a, h of x approach to 1, and the px approach to what? Approach to infinity. So like in here, we know the 1 over infinity, because numerator is 1. So the denominator become bigger and bigger. So what is here? So this is determinant, right? So the limit is equal to what? Is equal to 0. So this is a determinant. We don't need to use L'Hopital's rule. Okay, so now let's take a look at b's here. The b's here, this is the limit x approach to a, the f of x, and the gx, okay? So it's the same way. Let's say, hey, the f of x, the problem give us the f of x approach to 0. What is the gx? Gx approach to 0. Oh, I have a 0 over zeros, right? So that's why these terms here, I said this is indeterminate. Okay, so I will put a triangle here. So I know this part is indeterminate here, right? Okay, now let's take a look at part C here. So this is the limit x approach to a. So this is a px over f of x here. Okay, so let's take a look here. The px over f of x, the px, according to the given condition, px approach to infinity. What is the f of x? F of x approach to 0. Let's take a look. Is this determinant or not determinant? Okay, so when the numerator becomes very big, it's very big. Then when the denominator becomes 0, you will become very big also. So this one, in fact, it is determinant. So the limits here is infinity because they both approach to infinity, right? Okay, so be careful, right? So like for this type of the situation, I don't need to use L'Hopital's rule because I know this limit, some people say do not exist. All you say is approach to the infinities here, right? Okay, so let's take a look at D here. So this is the x approach to A. So this is h of x and the px here, right? Okay, so let's take a look again. So h of x approach to what? Approach to 1, right? So this one approach to 1. What is the px? Px approach to infinity. Okay, so now you have a constant. A constant is 1 times infinity. So what is this one here? This is infinity. So this is determinant, right? So this is determinant. So I know the limit is going to infinity. Okay, let's take a look at e's here. This is the limit x approach to a. Then I have this is f of x and the px here. Okay, so now let's take a look here. The f of x will approach to 0. The px approach to what? Is infinity. Okay, so I have 0 times infinity according to our form. So what is this one here? this one is indeterminate, right? So I'm put a triangle here, so I know that this one is indeterminate here, based on the rule we just reviewed, right? Okay, so now let's take a look at part F here. The part F here, this is a limit x approach to A and px, qx here, right? So now let's take a look at what is this one here. The px, what is the px approaching to? Approaching to infinity. What is the qx approaching to? Approaching to infinity. So what I know here is infinity times infinity will give you what? Will give you infinity, right? So this one is determinate, and the limit is in infinity here, or some people say it's not exist, right? All right. Now let's take a look at g's here. The g's here is the limit x approach to A, right? So I have f of x minus px, all right? So let's take a look here. So f of x approach to 0, right? So minus px approach to infinity. Oh, so in here you see the is a constant 0 minus infinity. So I know the whole things will approach to what? It's the negative infinity. So this is determinate form because it's a determinant is going to negative infinities, right? Okay, so now let's take a look. So I don't need to use the L'Hopital's rule. Okay, so this one here is the limit x approach to A, and this is the px minus qx here. Let's see what happens here. So when the px, the limit approach to A is infinity, qx is infinity. Oh, so this will become infinity minus infinity. So because it's infinity minus infinity, I don't know what is approach to, so this is indeterminate, right? Okay, so then putting a triangle, so we might need to use the L'Hopital's rule, try to help us to resolve it, right? Okay, so now let's take a look at i's here. The I is limit x approach to A, and then this one here is px plus qx, right? So let's try to take a look again. So the px is what? Px is infinity. What is the qx? The qx is infinity. So in here, I have the two infinities. So when I add them, so what happens here? I still get the infinities, right? So this is a determinant, right? So I know the limit is infinities here. Okay, so now let's take a look here. Now here, let's take a look at the k here, right? So k is will tell you is the limit x approach to A, and then here I have is f of x, then the power gx. So in here, x approach to A, so f of x equal to 0, and the g approach to A, gx equal to 0. Oh, so I see is 0 power of the 0. So by our definition, so this is indeterminate, right? So I put the triangles here. That means we might, we might need to find a way to, to solve it, right? Okay, so now the next one's here. Okay, so it's the L here. Oh, I'm sorry, I need to use the L's here, right? So here, L's here, this is a limit x approach to A, right? So this approach to A, and this is the limit f of x and to the px here. So the limit to the px, so in here we know this is the 0. Okay, so let's try to do here. So f of x, this is approach to 0. And then I approach to where? So to the infinities here, right? Px is infinity, right? So I know this one's here. I know the infinity to the 0 power is not, but 0 to the infinity. So this one I know is 0, so it's a determinant here. Okay, so that's why. And then the next ones here we talk about is the part m's here. So this is a limit x approach to A, and this is h of x and to the px here, right? So now you will see here, now let's see here what happens here. When the px is here, hx is infinities, right? So it's infinity. Then px, oh no, I'm sorry, the hx is ones, right? So, okay, so it's 1. Okay, so it's 1. Then px is what? Px is infinities, right? And so what is the here? Oh, I have that 1 to the infinity. So what is here is indeterminate. So we might need to use the L'Hopital's rule, try to help us here, right? So that's what is indeterminate. Okay, so now let's take a look. The next ones here is a part of n's here. This is a limit x approach to a and px f of x, px f of x, right? So here, the same way, so you put it in here, so you will get what? You will get px is infinity, right? So infinity to the 0 power. Then we see from the indeterminate forms. So what happens here? This is indeterminate, right? So I put the triangles here. So in order to find it, then we might need to, we will need to use might need to use the L'Hopital's rule to help us to find it, right? Okay, so that's good. Okay, so now do part of O's here. So this one's here, this is the limit x approach to a, and this is the px, the qx. Okay, so the px qs is here. So as you see here, the px is infinity. So this will be infinity to the infinity powers. So in these ones here, I know if infinity, you take it to the infinity power, it still become very big, right? So it's infinity. So this one is determinant here, right? Okay, so let's take a look at the part P here. Part P is here. This is the limit x approach to a, and then here you will have the px, and then you with the qx roots here, right? So let's take a look at these ones here. So this will be limit x approach to a, then sorry here. So this will be the px. What does roots mean? So it's 1 over qx, right? That's the roots mean. And now you will try to put the limit. So the px is what? Will be infinity. Then this one's here is 1 over infinities, right? So we know the 1 over infinities here. So this will be the infinities. Maybe I change to the color will be better. Okay, so this will be the infinity. So this will be infinity. This infinity come down here, right? And then what happened to here? Okay, so the whole thing's here. This is 1 over infinity. So this one, just like we did in the part A, so we know this one is what? It's zeros, right? So the whole thing's changed to what? Is infinity to the 0 power. Oh, so when the infinity to the 0 power, as we see from here, so it's indeterminate or determined. So it's indeterminate, right? So I'm putting a triangle on this province here. So as you can see, we practiced several, and how many we have here? 12. But we practiced 15 provinces here because I really want you guys to be, when you're doing the L'Hopital's rules, right? So the first thing you need to make sure is, they are really in the right form for you to use the L'Hopital's rules, right? So you need to first decide the limits they want you to find is indeterminate form or is already determinate forms, right? Don't just blindly, apply the L'Hopital's rules here. Okay, so this is our practice unit number 1. So in our next practice, we're going to go down the list for the indeterminate form. We're going to do the 0 over 0 form, infinity over infinity, and 0 times infinity. So for each one, you know, we have some type of the special methods which can help us to apply the L'Hopital's rules, right? So, but first things here is very, very fundamental. Make sure you understand which one is indeterminate, which one is determinate, all right? So remember, practicing, practicing, practicing. That's the way to make you better in math. Okay, it's nice talk to you, and I will talk to you again when we talk about the 0 over to the 0. How do we get the L'Hopital's rule work? Okay, so have a good day here. All right, bye.